We'll do 13. And ladies and gentlemen, stop talking. 13 is really just a fractions property review. Let's look at 13. We have f of x is equal to 1 over x plus 5. And we need to find f prime of 1, 1, 6. Now remember, I did show you how to do this on the calculator last time with a point, right? Yeah. I did not show you with a function, right? Like I didn't show you 2. All right, I will do that with one of the problems. So let's take a look. F prime of 1's definition is f of x minus f of 1 over x minus 1. What do we do then? We take the limit as x gets really, really close to 1. A duck question, but you need to know this answer. Why can't you just plug in 1? It'd be undefined because the what? Right, we cannot split the limit up of the top and the bottom if the limit of the bottom is going to 0. We can't do that. That's illegal. So what do we have to do? Some algebra first. So what do we do? F of x is equal to this, so we plug it in. Guys, there's way too much side chatter. I know you talked all last year in math. You can't do it this year. Beckman's really, really mean. Okay, so let me clean that up real quick. What's the common denominator of, if I just gave you that right there, what's the common denominator of that? Yeah, okay, so that's what we're going to do. Multiply this by 6 over 6. Multiply this by x plus 5. Guys, over x plus 5. So we take the limit as x goes to 1. What do we got? 6 over 6 times x plus 5. And then we're going to subtract that. It's a bad x. I need to write this bigger. Okay, I'm just going to clean up the upstairs first. I'm going to distribute that negative, combine some like terms. Notice I'm still writing the limit because I haven't done any calculus yet. I'm still doing pre-calc. I haven't done anything that has anything to do with calculus yet. So limit as x goes to 1 of 6 minus x minus 5 over 6 times x plus 5, all divided by x minus 1. That's just pre-calc. In fact, that might even be algebra 2. Stop and check up. All I've done is substitute use the definition, substitute in what f of x is. Shottery. No, it's x minus 1 because we are looking at 1. It's x plus 5 in the denominator. Nope, that's correct.
No, x minus 5. What? But it's
where you like right here. You want an x minus 5?
Like no, and then the one above shouldn't it be 6 minus x minus 5?
Nope, because it's x plus 5 in the original function. X plus 5 in the denominator.
Is it actually x minus or plus 5?
Yeah, it's x plus 5.
Well, that's why I didn't work.
Yeah, it's x plus 5. Copy the problem wrong?
Yeah.
That happens. A lot of AB kids did that first section of the test. They didn't like that I had the limit as x went to 2, so they just replaced it with infinity. All right. Well, they wanted. Of course, it's wrong.
Well, if they change the problem.
Ayana.
And they get it correct.
Ayana, let me ask you a question. You go in for appendix surgery. The surgeon's like, nah, that's boring. Let's take out her liver. Are you going to be like, good job. I just want to pay the appendix. You hope. You hope. Okay, so now question. I've got, here we go. I've got a fraction divided by something. What do I do to simplify that? A fraction divided by something. Yeah, reciprocate the denominator. How do I make the denominator a fraction, though? I put it over 1, right? Every single number you've ever had in your entire life is a fraction. We're just too lazy to write it. Like 5 is a fraction. It's 5 over 1. So let's copy that reciprocal. Let's combine some like terms. 6. Guys, stop talking. I got negative x. I got 6 minus 5. That gives me negative x plus 1. 6x plus 5 multiplied by. Now, again, I asked this key question. Why can't I just plug in 1? Why can't I just plug in 1? It would make a denominator 0, which would make it undefined. And I know it's not undefined, so I need to find something out. I know it's not undefined, so I need to find something out. Now, I look at this and I say, boy, this is the same thing, except the signs are what? Flipped, which means I need to take out a what? Negative 1. So that's what I do. Limit. And Napur, I'm just going through homework questions. I haven't done anything else yet. Negative x plus 1. Yep, that's a minus 1. Okay, now what cancels? X minus 1, x minus 1. So I'm left with negative times 1 gives me negative 1 over 6x plus 5. Now, you may say, why do I have to know this? Okay, AP test isn't going to give you an easy one, like what's the limit of x squared plus 2 as x is close to 4. It's going to give you something that involves one of those algebra tricks, either common denominators or having to use the conjugate to get rid of the square root. They don't assess you on pre-calc, but they put questions on there that you can't do without the pre-calc knowledge. So this one, now can I plug in 1? Yeah, 9 take the limit because the denominator is no longer going to be what? 0, right. It's not going to no longer going to be undefined. So I take -1, plug in 1. That gives me 6 times 6. So f prime at 1 is equal to -1 over 36. Yep.
Why do we always assume that the limit is a constant?
It could be undefined, but we know that this at its root is defined at 1. If they asked to find at -5, this would be undefined because it'd be going towards infinity. So we know that there is a limit that exists. Yeah, by just knowing a little bit about the original function. Other questions? I don't think that's all though. I think we actually had to do some of this. So then we got some more fun with that. Kiwi. Okay. Other questions? Okay. So now we got to do something with that. What do we have to do? We have to find the equation of the normal line and the tangent line. I'll do that once for you. The equation of the tangent line is y minus f of c is equal to f prime at c times x minus c. Now, a couple of you asked this via text. That's not solved for y. Can we have one that's solved for y? Sure, why not? What do I got to add to both sides? Yeah, this is the same equation. This is the same girlfriend. She just, oops, if I write it correctly. This is the same girlfriend. She's just all There we go. What's up? Yeah, there you go. Okay. This is the same girlfriend, just different makeup on. Same girlfriend, just different makeup on. Whether you use this one or this one, that's fine. Now, for those of you that took IB last year, IB is incredibly specific on the form you have to put stuff in. AP is not. If they ask you for the equation of the line, any correct form of the line will work. Which is why, if you have a correct form of the line, you do not simplify it. Why? Because if you simplify it incorrectly, what did you just lose? Your correct answer. Any correct form. AX plus BY is equal to C. Won't even talk about that until way at the end of the year when we're reviewing for the AP test, because that's just like a bugger they throw at you. This form, the top form, y equals mx plus b, all correct if they ask you for the equation of the line. Do not waste time or effort simplifying linear equations. Now, what should you get used to? Y equals mx plus b. We will only use that if we are given the y-intercept or it's really easy. Rather than that, this is our new BFF. Breebach, my boy, I heard him teaching this today. He was saying your first love is y equals mx plus b. But it's complicated. It's got life issues because it's hard to solve unless they give you the y-intercept. This is your new love. Why? Because it's really, really easy. Why? Because it's really, really easy. Okay, questions on that? Good job not laughing at that. I knew you guys weren't in middle school. Okay, his class, though, a little bit less mature than my class. So, questions on that? Okay, so let's plug in. We know when we put in 1, what did we get out as our answer? So I'm going to plug it in this one just because. Well, what did we get out when we found f prime of c? That was what? Was it positive or negative? I thought it was negative. -1 over 36. X minus, what point were we interested at? Plus, what was f of c? There's our equation. Do we simplify it? No, no, no. Leave it there. You're done. You got the right answer. Okay, for part B, you got to find the equation of the normal line. Normal line equation, y minus f of c is equal to -1 over f prime at c times x minus c. Then this should be an old friend from last year. This should be nothing new. So y minus 1/6 is equal to, well, copy dot reciprocal of that. That gives me 36 times x minus 1. Old friend from last year. Old friend. Stop and check out. Questions on that?
Waste your time.
Unless they give you the y-intercept. They give you the y-intercept, then you're good to go. In which case, it's the exact same equation anyways. Now, I have no idea why we teach that in Algebra 1 and Algebra 2 except to practice doing algebra. Except to practice. Now, again, if you were in IB last year, AP is different. AP is very non-specific. You do not have to have it in the form. Now, that's because you don't get a formula sheet. You do not get a formula sheet on an AP test, and those who took IB last year know basically every formula you need, you get on a sheet. Yes, IB classes, you get a formula sheet. Now, you have to take like 6 unbelievably hard tests in the same week. Fair enough. So, no formula sheet. You have to have everything memorized. Good news or bad news. You'll have it memorized whether you really wanted to. Like the limit definition. Somebody's going to ask you 5 years from now, you go, if x gets arbitrarily close to a, f of x gets arbitrarily close to L. How close? As close as you want. Wish I used that brain cell for something else. Okay, questions on that? All right, let's go to 2-2. Let's do a question out of there as well. 32. Let me look at that one. What was 32?
32.
Yeah, 32. Yeah, I can live without that one right now. 2-2. Let's look at 21 because I want to show you how to do it on the calculator too. 21. We are in a dark alley. What did they give us on 21? Yes. Yes. Okay, on this one, we have to find the derivative and then graph them. I don't really care if you graph it as long as you find it. So we learned last time that f prime of x was equal to f of x plus h minus f of x all over h. And we take the limit as h goes to what?
0.
0. What does h represent again? Distance between those 2 points. Absolutely, absolutely. Absolutely. Okay, so now here we go. So f prime of x is equal to, okay, this is not going to be fun. X plus h cubed minus 8x plus h minus f of x, the original function. Now, those of you who haven't had me before, you may say, why did I put that in parentheses? Anytime I substitute something in that's got a negative in front of it, I put in parentheses, so I remember to do what with both of those? Make them negative. Change the sign. Right on. Limit as h goes to 0 over h. Now, the question, why can't I just plug in 0? Yeah, you got it. Okay, so here we go. So f prime of x. Now, I assume that you either wrote this down in the notes or somewhere you've already done this. You don't have to show this 8 times. So that's equal to x cubed plus 3x squared h plus 3xh squared plus h cubed. You may say, how do I know that? Because I've just done it so many times, sadly, I haven't memorized. Another brain cell that I probably should have used for something else. Limit as h goes to 0, all over h. Then I distribute this, so that gives me minus 8x minus 8h. Distribute the negative, so that gives me minus x cubed plus 8x. Okay, have I done any calculus yet? No, I've done 0 calculus. This is all algebra so far. Questions on that? I'm just having fun with me and my algebra skills. All right, what cancels out? Hopefully everything that has a what? But no, right, because we got to take an h out. What cancels out? Goodbye, goodbye. What else? Goodbye, goodbye. What else? Okay, so this is equal to the limit as h goes to 0. I'm going to take the h out now. H, taking an h out of everything. So that gives me 3x squared plus 3xh plus h squared minus 8. Anything else? Nope. Now, I'm very aware that you learned the derivative rules, and you will learn them today. We'll remind you of all those shortcuts. However, in the back of your head, you still have to remember that this is the process that led to this. This is the process that behind the scenes got us this. Okay, what cancels out? Say that again, Kiwi. Sure, of course. I hate.
Say it again. I know, right? You can't hear if the door's open.
Yes. No, in fact, Kiwi, just start yelling at them in the hallway. Be like, I'm trying to find a difference here. No, not really. I only yell that when I see the business teacher across the hallway with like 6 kids in class. They're all talking. They all got their hats on. And me and Breebach like breathe fire and vengeance onto them. All right. I know. I don't care about hats, but it's a school rule. Like what? And Mr. Bailey like gave us a half-hour pep talk about enforcing school rules, and apparently that.
Have you read the dress code yet?
Is there a new one? Okay, here's the deal. If I see you wearing something you shouldn't, I just talk about it in terms of calculus. Like, let us say that a girl was wearing something that did not have any straps. I would say, "Whoa, you took the limit of straps as straps went to 0 on that outfit today." And then they're like, "Beckman, you're like the biggest nerd ever. Like, you're really gonna send me to the office of the calculus problem?" I was like, "No, I was just making sure you knew that the limit must exist, and it cannot be equal to 0. In fact, the limit needs to equal 3 or greater." And then they. Like I've just taken something and made it totally nerdy. Yeah. So I would encourage you, Ayana. Here's my challenge to you. In fact, you want to write an essay that's going to make a college remember your name. You write the new dress code in terms of calculus. Like for shirts, the limit as X approaches straps must be at least blank for all members of the domain. Don't even just say for girls. Just say for both boys and girls. Because you know some boy wears a wife beater, the straps are a little too short, and you're just like, cover that up. Nobody wants to see that. Like, yeah. I encourage you to write the dress code in terms of calculus.
Okay.
Okay. Like skirt lengths, yes. As X approaches the knee, X minus skirt length of skirt must be greater than or equal to. Yes. Yes.
Yeah,
No. That's why I teach you guys to do stuff so you can go do that stuff. Yeah, and imagine those poor Algebra 1 kids going, I have to wear like a parka every day to school, Mom. Like, look at this dress code. And the parents are just like, L-I-M? Limb. Limbs? Okay, they spelled limb wrong, the entire dress code. Okay, so then we take the limit as H goes to that. So, good news. Anything with an H goes what? Away. Why aren't you all laughing? Like, some of you are looking at me in disgust. If the dress code was written in terms of calculus, at least you would get it. Imagine everybody else walking through the hallway go, look at our new dean. She's so dumb. She spelled limb wrong the entire time. The entire time. And you're just like, she ain't the dumb one. Well, okay, what's that?
Okay, no, she was dress coding like some of the cheerleaders for our uniforms because like they show our shoulders.
They do.
Like that's not the dress code. The dress code doesn't say you can't show your shoulders. It says that's 3 inches.
I know.
More than
If
3
they wrote it in terms of limits, it would make so much more sense.
Okay.
So much more sense.
Or you could say it has to be at least 3 inches, which these are.
Yeah, but
You're required.
That's like school uniform. That's just so dumb.
okay, let's be honest with okay. This is live on the internet. Okay, cheerleaders' dress codes have been breaking dress codes as long as there's been dress codes. Yeah, it's way
I
too.
wear an actual skirt.
I went to Catholic school, and our dress code is you could wear a skirt, but it had to go at least 2 inches below your knee. Oh my god, yeah, I don't even think they make cheerleader skirts that long. So, and that was in the 90s. Yeah. So, okay, take out your calculator. Let me show you how to do this. Now, here's the bad news. Very rarely are there things that this can do that this can't, but this is one of them. This is, I only had just that little bit left. Okay, this calculator cannot do this. This calculator can. Let's actually, because this can get your derivative as a function. This can do it at a point only. This one can actually return like what is the derivative function. So let's actually plug this in. Let me show you how to do it on the calculator. Now, if it's worth 4 points, should you do it all on the calculator? No, that means I want to see it by hand. And there are, and again, the AP test holds you accountable for both. The calculator and doing it by hand are equal skills. One's not better than the other, which is a huge change for those of you that took IB. And you'll notice I'm teaching it the total opposite way they did last year. Last year, they didn't even let you use the calculator till the end. You must be able to use the calculator on every problem that you can. If you don't, I've put you at a severe disadvantage. And let's be honest, if you have to do this outside of this class, you're going to use the calculator. You have to be able to know what it does. So how do you go to basically everything on this puppy? You go to menu. And then what class are we in? Okay, now, last time I showed you derivative at a point, which does find the derivative at a point, but we want to actually find the derivative. So hit enter. So if you are new to this class, if you came out of IB, you only did stuff with X last year, and we're only going to do stuff with X for a while. So ddx, that means take the derivative with respect to the X value. You can do it with any variable. And for those of you that are going to take Calc 3, you're going to just do Calc 1 in 3 dimensions. But you got to tell it which one you want to take the derivative with respect to because everything else is a constant. So if you got like X, Y, Z time, and you want to take it with respect to time, it treats X, Y, and Z as constants. So you do have to tell it. The original function we had was X cubed minus, what is it, 8X? Now notice, is it going to return a number or a function? A function, because this will tell us the slope of the tangent line just by plugging it into this one. So hit enter and notice, it returns the function. Your 84 can't do that. That's one of the things this one does that one doesn't. Your mind can until you get some okay, let's be honest. Are these easy ones or hard? Yeah.
I'm trying to make it better because I don't have a cool one.
Shottery, don't say yes to a homecoming date until you get one. Yep.
That's how
You show us how to use the tangent line.
Hold on just a second. Can I play with that for just a second?
Yeah.
Other questions? Okay. Okay, hold on just a second, Cameron. Let me play with this for just a second. Okay, so let's go with that original function. So, okay, I'm going to be really honest with you. Last year, a girl in my class had this calculator. I had no idea it existed. So then she showed me, and I was like, holy cow, I have to get one. So then I had Kumar and Schwinghammer get me one. They also got one, too. They didn't return them, though. But I learned how to do this just by like literally we had a staff development day the day after I got this, and I literally paid zero attention the entire staff development day and just played with the calculator. And if you don't know what a nerd I am, I was sitting next to Breebach the whole time. I was like, hey, look what this can do. And of course the presenter's like, oh, man, this guy's really excited about this calculator or about what I'm presenting today, when really I had no idea. I couldn't even tell you what that day was about, except I learned how to play with this calculator. And it's incredible what this thing can do. So I understand you might not have $140. This is a good time to think, do I really need that second kidney? I mean, math gave you two. Do you really need both? Or do you need to trade one in for the calculator? Or, you know, I'm going to spend 6 hours with somebody at homecoming. Would it be a lot easier to tolerate them for 6 hours if they gave me a calculator first?
I should bring my calculator to homecoming. With Emily.
Yes, you should. Caleb, you should.
Caleb, only on one condition, that Emily also has one too.
I'll give her my.
Don't do that to her. Don't do that to her. Okay, so here we go. Cameron, let's take a look. So my function. Okay, so here's my function. Shh. And then you hit comma, right?
No, I found it.
Okay.
Comma X, comma point.
Isn't it that? Yeah.
Comma
there
X,
you go.
comma point.
Okay, so here's what you do. Here's my original function. So now you will also tell you the equation of the tangent line too. No kidding, it will. So I plugged in that I wanted to find the tangent line. Where was that? It was under calculus. You'll notice tangent and normal line are options under there. You plug that in. Now you got to think like you're using this calculator now. So how you have to program is like computer programming, because this is not in Pretty Print, which is all that really easy stuff to plug in. So then you hit the comma button. So you got to think. To do this, you got to tell it what the original equation is. You got to tell it you're taking the derivative with respect to what variable, and what variable are we doing now? The only one we know, x, and then what point, which is, pick one.
1.
3, 2.
People, the calculator's going to do it for you. Don't plug in 1. Plug in like 1/7, like something nasty.
6.
Hit enter, and look at what it did for you. Now notice, it did not say y equals, but here's the equation of the tangent line at that point. And notice, it even reduced the fractions for you. Now, will it do the normal line? Yes, it'll do the normal line too. If you go back to menu, everything's under calculus. You go down to normal line. If you type in the function again, like x cubed minus 8x, comma, x, comma, 1/7. Now, just as a reality check, notice it took the slope, took the negative reciprocal. Yeah, that would be a really ugly number to find that hand.
That's beautiful.
Yeah, but notice, seriously, look at what it can do by hand. Look at what it can do. Now, how long would it take to do by hand? You could do it by hand. You know everything you need to know. But part of this class is also teaching you how to use the calculator. If you don't know this, I have to sign something at the start of every year that swears I will teach you how to do this on the calculator. Because a lot of teachers do not have the independence where they say, if I give you the calculator, you still have to learn how to do it by hand. Now, you know, all of my tests are just like AP tests. Calculator section, no calculator section, multiple choice, free response questions. So just because I teach you how to do it on the calculator does not mean I forget how to do it by hand. It means I know how to do it on both. Now, here's the bad news. This calculator does it, the 84 doesn't. Now, do you know everything you need to know? Yeah. Does it take that long? Not really. But it's a big advantage having this calculator.
Is this the only one?
The CX, I believe, does,
No.
and the
No,
C.
It only
Nope.
does that point.
Oh.
You add a function.
Oh, yeah, because you need the computer algebra system to do that. Yeah. The computer algebra system is what the ACT does not like.
No.
Now, hold on just a second. I did actually learn this the other day, because I'm going to be administering the ACT October 16th or something like that. Okay, somebody asked me this question last time. Why does it have this thing? I know the answer now.
Yeah.
So if you want to use this on the ACT, and I'm going to What's that? Yeah, and like I said, that was only one person selling one calculator for $88. But if you watch it, the prices do go down this time of year because this is not the optimal time to buy them. There's more sellers than buyers. And here's the deal too. If you see like some person selling it on Amazon, offer them $20 less than what they got it for. If they say no, they say no. If they say yes, you just save $20. But there's hundreds of people selling these calculators on Amazon. They're not all going to get full price. Yeah.
So you can use the CAS on everything.
So you still can use it on the ACT, but you need to just make sure they have the thing that'll turn it into an 84. But yes, you can use this on the AP test. And I'm like, some of you were in, well, no, my TA isn't here today, that was, but Mohit was in the class last year, and Zoe Lee, if you remember, she was from Australia. Like, there's this really hard test that she took about 5 minutes on. And, you know, I did the teacher thing. Oh, I'm sorry, you didn't know there was a test. She said, no, I got 100%. It's like, how'd you know that? She's like, they're all right. I was like, how do you know they're all right? She said, I just put them in my calculator. How the beep did you put that in your calculator? And she shows me, and I was like, no. I was like, where'd you get that calculator? She's like, Australia. And then, of course, I'm like, oh, you know, can I buy one? And then I was like, okay, there's no way that's allowed in the AP test. And it is. And if you don't know, Mrs. Thurkel, that teaches up at LP, like, she's one of the senior AP graders. Like, she's been doing this for 37 years. I said, they really let these kids use this calculator on the test? And she's like, yeah, of course. You should tell your kids to buy one. And then I told the kids to buy one. And about a month later, almost everybody had one. And then we did series and sequences, and actually everybody had one. Series and sequences are hard. Josh.
I found the CX on Craigslist for $70.
Now make sure it's a CAS. Just a CX really isn't that much better than an 84. Yeah, this, in fact, Josh, let me show you. This is a CX, not a CAS, just a CX. And notice it's in that press to test mode. So really this just became an 84. But if you go into the calculate menu and you go to calc, you're like, oh no, look, it can only do that. And you're like, wait a minute, that's exactly what my 84 can do. It is. This is just an 84 with a sweeter operating system. The CAS has a computer algebra system, and that's what allows it to do all the sweet stuff to get infinity. Yep.
Remember that nasty interview you put on the board, or the nasty group you put on the board last year?
Yeah.
So we leave. First time I saw this thing, put it in your calculator and solve it.
Yeah, it's freaking awesome. All right, let's look at another one. We talked about 21. We talked about 15. Do we need to? Yeah, 15's interesting enough. Let's do 15. 15's interesting enough. 15. Yuck. 15. What do we got? 15. We've got f of x is equal to 5 square roots of x minus 1. So we plug that in the limit as h goes to 0 of f of x plus h. Minus f of x all over h. Now here's the bad news. That h is inside of a what? Square root. That's a really bad 5. Let me make that better. There we go. All right, so it's inside. What do we do with that puppy? Yes, we multiply by our old friend the conjugate. Really what we're doing is the difference of squares. And it turns out if you've got a squared minus b squared, that would get rid of both of those square roots. Now here's the thing that people forget. If you multiply the top by the conjugate, what do you also have to do? Yes, because you have to multiply by 1. This is inside of a limit. We can't just like multiply the whole thing by 5, even though some of you tried to on your test. I hate that fly. So multiply the top by 5 square roots of x plus h minus 1 plus 5 square roots of x minus 1. Yeah, I know, it's too long. Okay, 5. Okay. Now, why did I do that? Because I really want a squared minus b squared. I've got a minus b. How do I get the other part? I multiply by a plus b. Because we know a plus b times a minus b is a squared minus b squared. Now, there's, you see the trick, but then you also have to remember, you have to square both parts of this. So this is equal to 25 times x plus h minus 1 minus 25 times x minus 1 all over h times 5 square roots of x plus h minus 1 plus 5 square roots of x plus x minus 1. Now, some of you, again, are whining like I'm violating your civil rights, and I kind of have, when do we have to do that's not nice in here? You should have. These are on the AP test. I don't know why I skipped the hard ones. But let's talk about why we did this. Number one, why can't we just plug in 0 here? It would make it undefined. Now, let me ask you a question. If I plug 0 into that, does it make just this part here undefined? No. So if I can get rid of this h, it's okay that I've got something else in the denominator. A lot of you complained about that. Like, I can't do this because there's something still in the denominator. No, it's only because when the denominator is equal to 0, it violates those limit rules. There could be something horrible in the denominator. As long as it's not going to 0, it's okay. So don't just think the denominator is a place that there needs to be nothing. No, it just needs to not go to 0 as h gets really close to 0. So then you'll notice if I distribute here, in fact, let me stop and check up. That's a lot. Questions on that? Now, you'll notice, and Sean, I'll get you in a second, my class is going to be very comparable to a college calculus class. Like if you decided to walk over to the academy and take calc, you'll notice very, very similar problems, very, very similar outcomes. I'm not going to skip the hard ones. You guys are the freaking smartest kids at the school. I'm not going to skip the hard ones because that's really a disservice to you that I don't think you're smart enough to figure this out. And number two, I don't want, again, want you to go to college and like, I didn't know calculus. What's this limit is x? No. Boba. No. Calculus. Yes, I will teach it just like a college prof would, because here's the deal. You've earned the right to have that. And I know it's going to be hard, and you might get a B, and I could care less what your high school grade is, and you will 3 seconds after you walk across that stage 2, which I know for all of you is like, what do you mean I won't care about my GPA? That's the only thing I care about. Like, I have a girlfriend, and I don't care about her. In fact, I'd dump her if it got me an A in this class. Like, if Beckman said, dump your girlfriend, I'll give you an A in calc, she'd be gone before Beckman even finished. Like, I'd dump her butt on Instagram. No! Here's the deal. You care about the learning, and you care about the grade on the AP test, because that's going to get you out of college classes. Or I'd dump my boyfriend. Well, of course you would, because you didn't get your calculator yet. Now you realize, like, this really is something that's more important than the boyfriend or the girlfriend. It factors for me. He doesn't. It finds the equation of the tangent line for me. He doesn't even know what tangent line means. Okay, questions on that? Sean, yes? Not yet, because I got to get rid of this one. Yeah, I still got to get rid of the H, which means I just got to distribute. And then, I mean, you can see what's going to happen. 25. Yeah. Okay. So limit H goes to 0. I know a lot of you have just realized, like, yeah, this calculator will do more for me than my boyfriend. Like, yeah, I should trade him in for one. In fact, if your dad doesn't like your boyfriend, here's another way you can get the calculator to be like, Dad, if you give me one of these, I will dump him now. And I will even do it in front of you. We don't discriminate. There's no discrimination here at DCC. Okay, so what's that?
No. Caleb just tried to anger the internet. Half of it.
Okay, so what cancels out on the top? Yeah, 25, 25. Oh. Yep, there's an X there. Ooh, hold on. Hold on. 25X. Oh, there's the X. Yep. Okay, so that cancels that. That cancels that. What are we left with up top? What can I do with that and that now? Yeah. Okay. So now I'm going to take the limit. I'm not going to write it. So I'm going to take the limit. What's left on the top? No. What's left on the top? 25. Thank you. What's left on the bottom? Well, as this goes to 0, what's this going to get really close to? X plus 1. So I got 5 square root of X plus, is it plus 1? Nope, it is minus 1. That is a minus because that's a minus right there. I just copied it wrong.
Good Lord.
I know. If I were you, I'd go down to the office and be like, "This Beckman's losing it." No, it's not. Trust me. You just get a couple tears out. Counseling will move you. So, 25.
All right.
I don't get paid per student.
Oh, no, I'm not.
In fact,
No, you told me to go down there and like tell them you're losing it. So
it's fine. Bailey will be like, "We ain't cutting him." So
we're not cutting our stuff.
that's kind of cocky. I wouldn't say that. Okay, so there's our derivative. Because they're both divisible by 5 and 10. So I took a 5 out of both, just to pretty it up. Okay, 15. That's a good problem. That's a good problem. Yep.
So we could technically leave it as 25 over 10.
They will not let you leave it in terms that are that you can simplify. You do have to simplify it out. Should you change the form? No, you shouldn't change the form. Like they're not going to let you leave it as 14 over 7. They're going to make you get it to 2. Simple mathematical calculations that will make you cancel, but you should not change the form. Like I should not try to get rid of the square root in the denominator, which for some of you is going to blow your mind. Like 5 over the square root of 2 is a correct answer. Yeah, it is. They will not make you rationalize the denominator in the free response section. Some of the answers in the multiple choice will have denominators that have been rationalized, but you should be able to figure out which one's right without even having to do that. That type of strategy, though, is what we'll talk about after we're done with the course and just getting ready for the test. So again, those of you who took IB, notice there is a big paradigm shift from IB to AP. No cheat sheet, but they let you get away with a lot of things that you could have never gotten away with in IB. Like they will not make you simplify this denominator. That's fine.
Did you know in IB last year we got like Miss Madden right? She not only taught us how to use calculator, but she also let us use a manual when calculator on tests. What?
She is, like I look at her and I think that is somebody who's so much nicer than me. Like, I bet she even gave you like hugs in class, like good job. I bet she even called you your right name.
So she
Yeah.
She gave us like prizes
Andy,
before
yeah,
the
prizes, Andy.
Okay.
Yeah. She made us.
That's
I can see it.
yeah. Those of you that are in IB, the IB kids even gave him a really good compliment the other day. He said he's already one of us. Like we asked him how his day was, and he's like, ugh. Which you ask IB kids, so how's it going? And they're like, ugh.
It looks identical to a just Monsters University character.
Exactly. Or kids in the play, they're just like, eh.
That's why you have to make a conscious effort to put an actual emotion to your feelings.
Exactly.
Don't just
Yeah, no,
go
it's-
with
Yeah. And in AP, we're just like, what's the limit? Express the dress code in terms of limit. I'm not kidding you, Anna. That could be a great college essay. I took the dress code and I made it gender neutral by making it all about math.
was like, give a time and face adversity.
That's it, Luke. A time you faced adversity. I had to make the dress code gender neutral. What's more gender neutral than math?
How is that adversity?
Boom!
That's something you're choosing.
Because otherwise, like, Chaudhry, here's the deal. So, you know, we make some dress code that like says your skirt has to be 3 inches within your knee. And then, of course, what's some boy do? He wears his shorty shorts to school. He's like, this ain't a skirt. Hey, skirt. I'm wearing whatever I want. That would technically fall under skirt. I think that falls under the skirt category. Shorty shorts, because you know, back in the day, like in the 80s, boys used to be the ones that were wearing things too short. Like their shorts would be way too short. Yeah. Yeah. All right. Take out a sheet of paper. Split the first thing next to you. Actually, do we have time for this? Nope. Take our notes. Take our notes. Let's get smarter. Yeah, we ain't got time for that. I don't want y'all doing drugs this weekend. Nope. 2.3. Thank you, Caleb. All right, let's go. Notations for the derivative. Yep. All right, here we go, ladies and gents. 2.3, rules for derivatives. Ashton, that's why you couldn't see it. It wasn't on the board. Rules for derivatives. We're going to, okay, so there's a whole bunch of ways to say the same thing. There's one of these that we are being sloppy by even showing you today because I'm really not explaining what it means. That will become a big deal when we talk about implicit differentiation. And it's kind of like we're being a little sloppy with the definition right now, but then we'll come back and make it rigorous later on. These are all notations that mean the derivative. F prime of x, y prime, dy dx, d dx of f of x. They all mean find the derivative. In other words, find the function whose instantaneous rate of change will tell us what's going on with that function at that point. In other words, they're going to generate an equation that will tell us the slope of the tangent line. The derivative of the function tells us what the slope of the tangent line is when a point is inserted. It's like f prime of 2 tells us what the instantaneous rate of change is at 2, or the slope of the tangent line is at 2. There are a plethora of shortcuts for this. They are parts you probably memorized. We will go through those today. The only challenge in that is just remembering some of the algebra for the other ones. And today, if I have time, I want to convince you that the product rule and the quotient rule are the same rule. One's just a version of the other. In fact, one just has the denominator, just makes a common denominator of the other. I don't even know the quotient rule off the top of my head. I have to look it up every time because I don't ever use it. I just use the product rule. What's that? Yes.
Obviously.
Then no, minus no.
Thank you.
That's-
I always remember that one because denim makes more sense than Lodi high.
Like,
Lodi high or high
I know,
low?
Lodi high is like, how can you?
Wait,
It's like you're yodeling.
Lodi
All right, rule number one.
I remember that one.
Okay, the derivative of a constant is what?
Zero.
Why?
It's not increasing.
Right, a constant looks like this. Look up. Nothing's ever changing. What's the instantaneous rate of change at any point? Zero. Nothing's changing. Your relationship is constant. You never like or dislike the person any more than you ever have. Or your team is not getting any better or any worse. They are the exact same all the time, no matter what. What's the rate of change? There's no change. Zero. That's what the constant rule is. The derivative of any constant is zero. Now, we could find that involved. Now, here's again, in the back of your head, we could take the limit as h goes to 0 of f of x plus h minus f of x all over h. The deal is the numerator would be it would just be c times h over h, which is equal to c when we take the limit as that goes to 0 at 0. In the back of your head, every single one of these is a limit. In the back of your head, the mechanics of finding the limit that we did in the last two sections is always going on. We've just realized that there are some patterns that always exist. So the first rule is the constant rule. The second rule is the linear rule. The derivative of a linear function, in other words, c times x, is just c. Why? Because if you've got a straight line, what's the slope? The slope. What's the slope of any point? The same slope. So y equals 7x. What's the slope all the time? 7. So in other words, a specific example, looking at example number 1, f prime of x is equal to what? What's the derivative of x? 1. F prime of 3x is equal to 3. Easy enough. Why? Because the slope is constant. Going back to the glory days of algebra 1, why can you pick any 2 points to find the slope? Because the slope is the same between any 2 points. What's the instantaneous rate of change at every single point? Whatever the slope is. Bad news, you could actually be asked an algebra 1 problem in calculus. Like if in fact, you remember on the I don't remember if this is on your practice AP test or not, but there was one that you just had to find the slope between 2 points. They didn't give you the function. And they gave you one of the 2 points as C. All you got to do is find the slope between C. Okay, Neil, you have an immediate pass. Go. You get so excited about calculus, you forget all these trivial details in life. Okay, questions on that? Okay, number 3 is the power rule.
Finally.
Power, base, 1 less power. Power, base, 1 less power. So if you have x to the n, power, base, 1 less power. Now you may say Beckman, but I learned all these cute ways last year. Beckman is not a big fan of cute. Beckman is a big fan of rigorous definitions. Like, I don't want you to ask some girl out. I want you to say, can I pick you up at 7 o'clock, take you out to dinner, take you to a movie, and return you safely at home by 9:30 so your dad's really happy? Of course you can.
That's a quick movie.
7 to 9:30.
It's a quick dinner, not a quick movie. I'm taking her to a really expensive one down in Pueblo. Or they're building that one up at Colorado Crossing. So the ones that you actually, like, you sit in the chair and you order dinner at your seat while you're watching the movie. Yeah.
Windows are so
They are so nice. So nice. What's that?
I saw that one's supposed to be done.
It's supposed to open in November. It's almost done.
Really?
Like, the issue they're running into right now is that old road that's actually connecting it is so busted up, they decided they had to redo it.
Yeah.
So they might actually start with a gravel road there, but those are super nice.
Wait, right across from Blue Light?
Yeah, right across from New Life. Yeah, it's almost done.
I thought it took a lot longer because they had to fix a bunch of weather damage from past like 8 years.
That is what the paper, there's actually an article in the paper on Sunday about it, about yes, the part that they're constructing now is almost done, but they're running into all these issues because that basically sat empty for a decade. So
Yeah.
they're finding things that are broke that were supposed to already be done. So November is the date they had in the paper on Sunday though. So maybe.
The movie theater?
Yeah, it's a brand new movie theater. It's across the street from New Life.
So it's going to shut down the interest.
Hopefully not, but that, I love that one because it's like practically empty all the time anyways.
Yeah.
Okay, the sum rule. Find 4, the sum rule. ddx of f of x plus g of x. Can you break it up? Yes, you can. Just take the derivative of the first plus the derivative of the second. Constant rule. And notice I'm going fast because I'm hoping you remember these from last year with just a very small reminder. Yeah, that's because the word function's in between it. Constant function rule. So you've got some constant times f of x. That's just equal to the constant times the derivative of f of x. So 3x squared. 3 times the derivative of x squared. Now again, I'm going fast because if I can count on anything, I can count on you remembering memorized rules. Okay, 6, difference rule. Can you break them up through subtraction? Yes, you can. It's equal to the derivative of the first. Yeah, good. Where? Oh, that's a minus. Definitely a minus. Definitely a minus. Okay, so you're saying to yourself, trivial. Yeah. There's got yeah, product and quotient in the next section. Okay, and the last one, I don't know, I can get through more than that today. E to the x. Not talking about composites yet. We'll get there. The derivative of e to the x is e to the x. Why? We prove it next semester. It's a series. E to the x is a series. Where's Caleb when I need him? He'd be like a crazy chipper to talk about this. Caleb, I tried, brother. I tried. All right, let's take a look at some examples. Now, notice I'm going very quickly because I assume that this is something you covered last year. So let's go example number 2. Find the derivative. I think I did an example in one of them. Yeah, I did. Okay, let's go for 3x squared plus 7x plus 6e to the x minus 16. What's the derivative of that? On your marks, get set, math. Can I cover the product rule today? Yeah, we can cover the product rule. Look at us cooking through this. We might even get to a chapter test by the next week. We might be able to get it in before homecoming.
Sorry about the first test.
I told you a week. I'll have it done by tomorrow. I'm not Kumar in that regard. I don't buy that self-grading paper. Okay, now I know you don't think this way, but you should. Can you break this up into the derivative of the first plus the second plus the third plus the fourth? Yeah, you can, and that's what allows you to just treat each one individually. Why can you do that? Because in the background they're all what? Limits, right? In the background they are all limits, and we can break up limits through addition. We can break up limits through subtraction. We can break up limits through constants. We can break up limits through powers. That's what allows us to do with the derivative, because the derivative is just a limit. In the background, all of these are limit problems. Now, I know you don't think of them that way because you memorize the rules, but in the background, they're all limits. Okay, so what's the derivative of 3x squared? What's the derivative of 7x? What's the derivative of that? Because can you bring the constant out? Yes. What's the derivative of e to the x? E to the x. What's the derivative of 16? 0. Yay. Questions on that? Okay, yes.
Are nothing and 0 the same?
Ooh. That's when I hand back your test, I have to talk about the difference between does not exist and undefined, because there is a difference between the two. I never use the word undefined when talking about a limit. It either doesn't exist, going to infinity, or going to a number. A lot of you wrote undefined, which limits cannot be undefined. They cannot exist, but they're not undefined. Because if a limit's undefined, it's probably either going to infinity or negative infinity, or it's oscillating. If it's oscillating, the limit does not exist because you're not getting arbitrarily close to something, which I know is nitpicking. You're like, why is calculating so much harder than Calc 1? Because it is. And because you have Beckman. He's a jerk. But he's going to have you ready for college. Because you're going to go next year, and all these kids are going to be like, we didn't use those words in high school. And you'll be like, we did in my high school. And they're going to be like, man, you are so
So
smart.
it's a nice journey.
Yes. Because here's what you guys are complaining. I have a B minus. I have a B minus. I have a B minus. I'm not a good person. No, having a B minus has nothing to do with being a good person. There are plenty of good people who get like straight D's in high school. Nothing to do with you being a good person. In fact, your grades really have nothing to do with who you are as a person. It might be a part of it, but it's not like my defining characteristic. If your GPA is your defining characteristic, you're going to have a really hard time after you walk across that stage in high school and you realize my GPA doesn't matter anymore. You're like, now what's my defining characteristic?
It does not exist.
Okay, product rule. Now we get to a fun one, product rule. Now you'll notice I'm not a fan of cute. I'm a fan of rigorous definitions. So now we got to find the derivative of two things that are being multiplied by each other. So you've got two functions, a first function and a second function. Now, I really don't always know where everybody comes in on this. So I'm going to show more work as a teacher than I would as a student to show these out. I'm going to show more work as a teacher than I do as a student. Why? Because I want you to know how to do this regardless of how you came in this class. So what's this equal to? That's equal to the derivative of the first thing times the second plus the derivative of the second times the first. The derivative of the first times the second plus the derivative of the second times the first. It's like you treat the other function as a constant when you're taking the derivative of the other. So if you're taking the derivative of x, it's like you treat g of x like a constant. Huh, like that's going to come up in Calc 3 too, because it is. So notice when we're not taking the derivative of that, we treat the other one like it's a constant. Again, in Calc 3, if there's x, y, z, t, and you're taking the derivative with respect to t, suddenly x, y, z are all constants. Here's the good news, though. Calc 3 is really easy after taking this class. In fact, I'd expect you to do, like, get 100% in that class. Never miss anything ever. I know somebody who did. Okay, questions on this one? Yep. Now, that depends. Like the Air Force Academy, we will do Calc 1, Calc 2, Calc 3 for the Air Force Academy because they only meet for 43 minutes, 3 days a week. So like we will be done with their Calc 1 class by like fall conferences because they only cover the derivative in Calc 1. They don't even talk about the integral. Then Calc 2 is really all about the integral. If you took Calc AB last year, you actually took Calc 1 and almost all of Calc 2 for the Air Force Academy last year. But that's just because they only give Calc 3 credits. Like my college gave Calc 5 credits, so it covered all of Calc AB. So it just depends on what college you go to and how many credits they give. But yes, I have had kids go right to Calc 4 out of Calc BC. Yeah. All right, let's take a look at an example. Easy one or hard one? Hard one. Example number 4. Let's go for, we need to find the derivative of what? Oh, it's 3. What should we find the derivative of? Yeah, let's go for 3x squared plus 7x plus 1 times 6, yeah, let's go 6 e to the x. Yeah. Okay, so here's what I do. If you are new to this, I'm introducing this like you've never seen this before. If you've used this before and you're confident, you may not show this step. Here's what I do with this. I always identify what is the first function, what is the second function. Okay, then here's what I do. I write the derivative of it right below it. All this is doing is organizing my thoughts. That's it. All this is doing is organizing my thoughts. So I identify what the first function is, I identify what the second function is, and then I take the derivative of each. The derivative of 3x squared plus 7x plus 1 is? The derivative of 6e to the x is? Okay. Then I just fill in the blanks into my product rule. I just fill in the blanks. So d dx of 3x squared plus 7x plus 1 times 6e to the x is equal to the derivative of the first times the second. So then I use the original function plus the derivative of the second, coincidentally the same thing, times the first. So you'll notice they kind of go with the things that are in the opposite side. So there's also a visual, like that's what goes together in the product rule too. That's 3x squared plus 7x plus 1. Sorry, hashtag budget, guys. Now, yes, yes, yes. Trivial, trivial, trivial. Trivial, trivial. Yeah, I'm being serious. We probably will have a test before homecoming.
Spring break.
Oh yeah, you don't have a lot of tests for spring break. Yeah, I think we're gonna be able to fit it in. I was really hoping to get to that. So we got Monday, Wednesday, Friday next week. We'll have a test next Friday.
Sweet.
Now, I'm doing you a favor because I'm making it before homecoming week. Don't even look at me like I'm being mean, people. If I give you a test during homecoming week, you're going to walk in and be like, I had to stay until 4 in the morning getting my boy dressed up, and then I had to wake up at 5 in the morning to get him actually dressed. Yeah, I count on getting nothing done during homecoming week, so now I've got your test up. What's that?
Next Friday.
Next Friday, yeah. Hashtag my wife's birthday. Present for you. Yes. Okay, so questions on that? Now, I want you to hear this part. I go fast, but I don't want to go in a hurry because I don't want to waste your time on things you should already know. Now, if I need to, that's why I always stop for questions, though, because I am kind of fishing for where you guys are on this. I'm always fishing for where my students are. If I need to slow down and say, hey, can you explain that again? Of course. But I also don't want to waste your time and spend a month on this when I'm going to need all the time I can get for the stuff in C. The C stuff is the hardest math you will have ever done in your life. And if you really want to feel smart, just show somebody what you do next semester and say, hey, read this. Don't even ask them to do it. Just be like, read it. And they're going to be like, I can't even read that. Yep.
So I
Not yet, because I got like 2 minutes left.
I would let you leave it in the
So what we will do with this right now is leave it in this form. When we have to solve it, like set it equal to 0 and solve, then we'll talk about what we want to do. But for right now, no, that's totally fine. In fact, you only expand things out when you have a reason to. Right now, we do have no reason to expand that out. Now, could we combine some like terms? Maybe, but I'm not going to lose sleep over that right now. Okay, let's give you some fun work to do tonight. So I give it to you before you leave so I don't have to worry about my shottery text at 5 o'clock threatening me. So page 190.
Are you also going to send this out over?
I always send it out over Remind. Let's do, these are trivial, 1 through 25 odd. Yeah, 1 through 27 odd, because I want you to hit 27 too. Trivial 47.
Can you send them out over your?
I will, yep.
Okay.
47. 47 is a beautiful problem.
I appreciate it so much that you send out the word because I don't have to try to remember anything.
No worries. 55.
And you already know. I checked.
Okay, then on page 192. Two, 4, 6, 10. No, 8 isn't that good. And then on 193, no, sorry, that's not 193. We got to do some quotient rule or some product rules. Let's go for page 201. Let's do which ones? Let's do
1 through 11.
number 2, number 9, 16.
1 through 5.
No, the bells are rang yet. Yep. I didn't talk about that. That's Sad Panda. No, those aren't good problems. That's sad. 205. What can I do on 205? Uh-oh. I can't do much. 5. That's it. Sad Panda. The bird.
I have this